All, welcome to my YouTube channel. I am Shakti, and today we will continue our fake news classifier part 2. And this is we are doing on LSTM deep learning method. So far we have done only until exploratory data analysis. Now we will continue with our embeddings, padding, and one hot representation. Those stuffs we will continue now. So first of all, we have to get our vocabulary size. We have already have our corpus and we have added to our data frame. Now we will get that unique words of our corpus. So for that, what we have to do is like from keras preprocessing dot text import tokenizer. Tokenizer of fit on text of either I can give corpus or df of cleaned. Now vocab size is equal to tokenize dot index length. So our vocabulary size is 13931, the total vocabulary size. And now what we'll do is like we will set the length of our sentence. Let's say like I'm giving the sent length is equal to 50. Okay, and the features for our embedding layer is 100. Okay, now we have our fixed length 50 and the vocab size is 3931. Now what we have to try to do is like we have to put a one hot representation so that all that data will have the same length while giving to our network. So for example, like a df of cleaned of 0, if I print this, okay, this is what it comes, right? And let's say now we will be giving one hot representation of this. Okay, first of all we'll give the one hot representation, then we will go with the padding. From keras dot and pre-processing this is for pad sequences and for one hot encoding one hot. Okay, so one hot equal to one hot of, and we have our corpus. No, we have to set one hot like for the number of words in the corpus. So I comma vocab size for I in corpus, and this has to be put in a list. Okay, one hot of 0, one hot representation is equal to okay, now this is 1 2 3 4 5 6 7 8 9 10. So it has list of 10 values, but we have we're gonna say length of 50. So for the remaining words we have to do padding. We can add it at the front or the back. but here we will do padding at that we will do post padding. Pad underscore sequences, we have to pass this 1 hot rep padding underscore max length is equal to our max length is equal to, what is that length? Sentence length. Now padding of 0. Now the remaining values are filled with zeros. Now this will be given as an input to our model. Okay, and okay, first of all we will split the data from sklearn dot model selection import train test split. So x train comma train test split here. No, our 1 hot represented 1. No, the padding one. Padding comma df of label comma test size is equal to 0.2 and stratify equal to df of label random state equal to 1. Okay, what is the size of x train dot shape? 14628. So what is our y train? 14628. Okay, now we will build our model from keras dot import LSTM comma dense comma embedding comma dropout. From keras dot sequential of, we will add our first embedding layer and embedding of and vocab size, and what else we have, that features, embedding features, regularization activity embedded constant and ask 0 input length sent length. What is the error? Import den, okay, DENSC. Okay, dropout of 0.3 model dot add of LSTM. See, dropout is like it will set that input units to 0 during that iteration, during the training iteration, so that it doesn't get overfitted. When LSTM it is a sequential model, right? LSTM, so we'll have an embedding layer and LSTM followed by our dense layer. You can have any number of dense layers, dense units and LSTMs provided with a given dropout in between, so that it doesn't fall into overfitting, so that it will initialize that input unit to 0. Okay, so now for us, we will keep it as simple like one dropouts before and after LSTM. Then we'll go with only one dense. Add a dropout of 0.3. Okay, wait, go. Dense of, it's just we are giving only dense of only one layer, and if want we can give any other layers before this dense, but right now I am giving only dense with just only one, which gives a which classifies either the 1 or 0 with an activation function as a sigmoid. Activation function as sigmoid. Then we will compile. The loss function should be binary cross entropy, since we are giving the binary classification, and optimizer equal to matrix is equal to accuracy. Okay, it works. So model summary of okay, this is our summary about our model: embedding layer, dropout, LSTM, dropout, dense. Okay, now what we have to do, we have to fit our model. Model dot fit off, we have x train, y train, validation data equal to x test, y test, test size equal to 0.33, and we don't need test size. I think this is fine. Got an unexpected, okay, random, then I think they should not be part of this. Okay, model dot fit off, I can put one okay, I didn't specify what is that. Binary cross entropy, please ensure this objects of custom arguments. Binary cross entropy, this is this one, and pux equal to 10. Yeah, batch size is equal to 128. Okay, finally it's running now. Batch size is like 128. If you're ideally we should run with 64, but since I'm running in yeah, this is fine. See, even though if I run in 128, if you run in if you decrease the batches, it will take some more time. So it's like its validation accuracy is 92%, so it's pretty pretty decent. Now we will, what we can do now we will plot the accuracy of our train and test, and we will see. plt dot plot of model dot not model, I think final model accuracy, and plt dot plot of final model dot history accuracy. That's all. Then next label of epochs, label of accuracy, and plt legend of train comma test. Okay. So for our say for the first epoch, it starts from around 0.75, then it came down, and during our third epoch it went up, and our accuracy it's remained constant till that 90%. So it's the model is getting trained perfect, or it's getting picked up from the epoch 3 and more. Same way we can plot for our what is that, our loss. So how we bring down our loss? Okay, see, then it is ideal at epoch 4 the loss is getting minimum for the train data, but for the test data it's still the loss is getting stagnant. So this is this is a very simple model. So what we can do is we can just fine tune our model. Here also I can add one more dense, instead of this dense is 1, I can add it as a dense 64, and I can add another dropout and LSTM and another the final dense one, and we can keep on training our model. That is what we call as fine tuning our model until we get a better results. Okay, and so once we have our test data, the actual if you look at the Kaggle data set, we will have both train and final CSV, the summit CSV, and we can use our final CSV and pass it to our trained model and see how it is fitting it, or how that results are. So that is how our actual validation. So but for now we will stop it here, and we will see with another topic in our next video. Thank you all. Bye.